Okay, so last time we reviewed induction, and now we're going to be talking a little bit more about how we can use what we learned in questions. But before we get started, I just wanted to make sure that everybody understood that excess charge in an object is actually related to the surface area of that object. So the charge is going to spread itself apart as far as possible. So it's going to go towards the edges of each object. So if it's a uniform object like this sphere, it's going to spread itself out as equally as possible. If it's not uniform, like this oval shape here, it's going to find that narrowest area that's going to be like near the edges right here, and not so much over here. You can see there's more charge here than there is here. And then the last thing is how easily charge flows on a body or from one body to another is dependent on that material. So if it's a conductor like a metal, it's going to allow the flow of charge, so these electrons can move very easily. Whereas in insulators, they're going to not allow that. They're going to be stuck in their positions and bound to their nuclei and protons. So let's take a look at 2 or 3 questions that use these properties, and we'll kind of be able to apply what we learned. Okay, so the first question here says, one way to give a graphite-coated sphere a negative charge is to touch it with a blank charge rod, and this process is called charging by blank. So whenever you see the word touching, you're going to assume that it has to do with conduction, and that's simply because when you touch something, you're going to be spreading that charge. And if it is graphite coated, that means it is a conductor, which means conduction does work. So when you touch it with a charge rod, whether it be positively or negatively, we'll see which one it could be. Sphere, a negative charge. So you want to give it a negative charge, which means that the actual rod has to be negative as well. So the answer would be this one here, which is negatively and conduction. The reason why is because when you do it, you're going to have that same charge. And you can see in this diagram here. Okay, so the next question is about the movement of charges. So 2 neutral metal objects, X and Y, are placed on a wooden table in contact with each other. And then a negatively charged rod is brought near Y, and while the rod is nearby, the metal objects are separated without grounding. So this without grounding is a big thing because it means that it's just going to have charge separation happening within the 2 bodies. And if both of these are metal, that means they're going to be able to allow the flow of electrons to move from Y to X or X to Y. So because this is negative, all the negative electrons are going to flow this way. They're going to flow to the farthest possible side from that rod, leaving this Y cube being overall with a positive charge because of a deficit, and this one with an excess, meaning it's a negatively charged rod. So basically, this presence of that negatively charged rod creates this charge separation and induces these type of phenomenon within these cubes. So the right answer for this would be, okay, so not conduction. It is induction because they're being induced. We're not actually touching it. So object X receives a negative charge by induction. Object Y receives a positive charge by induction. So correct. So I would say this one right here is good. So anytime you see conduction, it is going to be wrong. So you can cross out this, and you can cross out this too because they're going to have opposite charges. So the answer is the second one. Okay, now 14, so the third question. A student places a positively charged sphere near a metal rod. Both are insulated stands in the ground. The rod is grounded. Okay, so what's going to happen here is that positive charge is going to gather electrons to this X side, and then when you ground it, there's going to be more electrons flowing in to combat and to fulfill this. So what we're going to get is a negative end at X, and electrons move from the ground. So